Good day, we'll be discussing the graphing rational functions. So last time we've discussed how to find the asymptotes and the intercepts. Now we'll proceed with the other steps in graphing rational functions. Remember that a rational function is of this form, a polynomial over a polynomial. And the domain of the rational function is the set of all real numbers except the zeros of the denominator, and we've discussed this already from our previous videos. So we have these steps. So last meeting or last in our previous video we've discussed numbers 2 and 3. Now we'll be plotting these points. So last time in our previous videos we've discussed how to find the asymptotes and the intercepts of these 5 rational functions. So let's go with number 1. So from the previous video we have this. The vertical asymptotes are x equals 1/2 and x equals -4. Horizontal asymptote y equals 3/2. X-intercepts we have -1/3, 0 and 3, 0, and the y-intercept is, this is supposed to be 0 and 3/4, okay, because it's the y-intercept. The x must be 0. Okay, so let's plot the points or these lines. The vertical asymptotes we have x equals 1/2. So here on the x-axis we have x equals 1/2 here. This broken line, this is x equals 1/2, positive 1/2. So it's at the right side, 0, and it's between 0 and 1. Then we have another vertical asymptote. We have x equals -4. So on the left side we have x equals -4. So this is -4. Okay, next we have the horizontal asymptote, y equals 3/2. Y equals 3/2. 3/2 is equal to 1.5. So it must be between 1 and 2 on the y-axis. So this is the y-axis. So therefore this is our y equals 3/2. Okay, between 1 and 2. So this horizontal broken lines. Next, the x-intercept, we have -1/3. So this one, this is -1/3, 0 here. And next we have 3, 0. So this one, this is 3, 0. This is another x-intercept. And last we have the y-intercept. So the y-intercept is this one. That is the y-intercept. Okay, so that is the y-intercept. Okay, next is we need to arrange all the values from the vertical asymptotes and the x-intercepts. Meaning, we'll arrange the x values of these two, the vertical asymptotes and the x-intercepts. So we have 1/2, -4, -1/3, and 3. So we will arrange them. So the smallest is -4, then we have -1/3, then we have 1/2, and then 3. Okay, the same thing will happen in our previous discussion with the rational inequality. So we'll locate the these numbers on the number plane. So we have -4, we have -1/3, we have positive 1/2, and we have 3. And of course, this is -infinity and this is positive infinity. Okay, but this time for the intervals, we will only be using the parentheses. Okay, brackets or parentheses will not be that important anymore because we'll just be connecting our points and drawing lines later. Okay, so just use parentheses for the interval or parentheses. So therefore we have these 5 intervals from -infinity to -4, -4 to -1/3, -1/3 to 1/2, 1/2 to 3, and positive 1 and 3 to positive infinity. Again, we'll have test points. So the same thing, give a representative of these intervals, only 1 point. So -5, I can have -1/3, 0, 1, and 4. And then next, this is the numerator, this one, and this is the denominator. And the last one, of course, is the numerator divided by the denominator. So here, if you notice, these are signs, positive and negative. So all you need to do is, again, substitute these test points on the given expression. Okay, so meaning for this one, why is it positive? We have 3 times 5 squared minus 8 times 5 minus 3. So this is 3 times 75 minus 40 minus 3. Okay, this is 25, I mean 3 times 25. Okay, and then 3 times 25 is 75 minus 40 minus 3. So this is now 75 minus 43. Obviously, since 75 is greater than 43, so this will become positive. So that is why our symbol here is positive. Okay, and do the same thing to other cells. Okay, so we have these signs. After this, we will do the division. So positive divided by positive is positive. Positive divided by negative is negative. Negative divided by negative is positive. Negative divided by positive is negative. Positive divided by positive is positive. Now for the graph, for the last part, so this is where we draw our curve and connect the dots. So if it's positive, it means A, where A is, we will draw a curve above the x-axis. So meaning, if we have this is y, this is x. So above the x-axis, say for example here, so we must draw a curve here above the x-axis, as long as it is above the x-axis. And the B, if it's negative, it's below the x-axis. Okay, but before we graph this one, we have this question. Okay, say for example, this one, before we go to the question. So we have this at the last two columns. We have the above, below, above, below. So here on the first part, this is negative infinity to -4. This is -4. Our graph or our curve should be above the x-axis. Okay, so that is why this is the x-axis. So later we'll know why we will draw the graph here and not here. Okay. Now, why is it here and not here at the lower part? Okay. Next, on the -4 to -1/3 on this interval, it should be below. So from this point, so this is the intercept, it means that the graph will cross here or will intersect the x-axis. So it is below. So from here, it should be below to the left, not to the right. It should be to the left because the interval is from -4 to -1/3. Okay, the interval is here, -4 to -1/3. So it should be from this point to the left, from the point of intersection from the x-intercept to the left. Okay, next is -1/3 to 1/2. So -1/3 to 1/2, it should be above. So it means this interval, this small interval here. And since we have a y-intercept here, this one, so the graph should cross there. Okay, so we should connect that and then it should move. It should approach the vertical asymptote. It will not touch, but it will just approach. Okay, so above, so just draw a curve above towards the positive infinity. Now remember the definition of the vertical asymptote. F of x approaches positive infinity or negative infinity. So since we're going up above, so it should be to positive infinity. And if you notice, it crosses the y or the horizontal asymptote. Okay, so as what I've told you in the previous video, although it's an asymptote, the horizontal asymptote we can cross, or the graph can cross the horizontal asymptote. And we will know this point here after this slide. Okay, so I repeat, so in this interval, negative 1/3 to 1/2, it is above, so we'll just draw a curve above the x-axis. So this is the x-axis. So above, it should be this one. Okay, next, let's go to 1/2 and 1/2 to 3. So this is 1/2 to 3, this one. Now it is below. So if you notice below, so take note, this is our, we have a point here, the another x-intercept. So we must draw a curve to the left. It should be below. It should not be to the right because the interval is until 3. Okay, you do not draw a curve here, okay, because the interval is only until 3, negative 1/3 to 3. And then last, we have 3 halves, 3 to infinity. So from 3, so this is now 3 to infinity. So just draw a curve here. Okay, now it should not cross this horizontal asymptote. Why? Because we can only cross the horizontal asymptote if the graph can cross the horizontal asymptote, it can cross only once. Only once. Okay? Since it already crossed, or the graph already crosses here, or cross this part, this horizontal asymptote, then these other two graphs should not cross the horizontal asymptote. So that is why this should be above the horizontal asymptote. Okay, so now before we look at the overall graph of this one, I have a graph of this one, we must first look at this point of intersection here. So will the graph cross the horizontal asymptote? To answer this, we must equate the function. So this is our f of x, and the horizontal asymptote. So this is our horizontal asymptote. Y is, remember, as per horizontal asymptote is y equals 3 halves. So that is, we cross multiply. Okay, so we have 2 times 3x squared minus 8x minus 3. And on this side, we have 3 times 2x squared plus 7x minus 4. So distribute. So we have 6x squared minus 16x minus 6. Then 6x squared plus 7x, 21x minus 12. If you notice, we can just cancel this out. Now, if we transpose 6x squared on the other side, it will become 6x squared minus 6x squared. So it will cancel out. It is 0. Okay, so we're left with, again, this is cancelled out. We're left with x and this term without x. So I will transpose negative 16x. So this will become positive 16x. And negative 12, I will transpose it here. So we have positive 12. And just copy negative 6 and positive 21x. 12 minus 6 is 6. 21 plus 16 is 37. So we have 37x. And dividing both sides by 37, this is x is equal to 6 over 37. Okay, so this is approximately 0.16. Okay, so it's very small. So therefore, the graph will cross the horizontal asymptote at 3 halves, since this is a y, 3 halves, and our x now is 0.16. Okay, so therefore, yes, the graph will cross the horizontal asymptote at this point. And remember, only once. The graph will cross the horizontal asymptote only once. So we have this. So meaning the graph will cross here, positive 0.16, so somewhere here, very small. And of course, a 3/2. So this somewhere here. Okay, so therefore, I will graph this again. The graph looks like this. Okay, so above, below, above, below, above. Okay, so using your Desmos or your Google, you can check, or your software, you can check that the graph will look like this. Okay, so this is now the graph of 3x squared minus 8x minus 3 all over 2x squared plus 7x minus 4. Okay, next, let's try example 2. So from the previous video, we have this horizontal asymptote, vertical asymptote, and the intercepts. So our vertical asymptotes, we have two, the x equals 1 and x equals negative 1. Our horizontal asymptote is y equals 0, or the x-axis. So since this is the x-axis, so you cannot see any broken lines anymore because this is the x-axis. The y-intercept and the x-intercept are both at the origin. So meaning the graph will intersect the x-axis and the y-intercept at this point, or y-axis at this point. Okay, so next we'll arrange the values from our vertical asymptotes and x-intercept. We have negative 1, 0, and 1. So negative 1, this 0, and 1. So therefore we have negative 1, we have 0, and 1, and we have negative infinity to positive infinity. So these are now our intervals, negative infinity to negative 1, negative 1 to 0, 0 to 1, then last 1 to positive infinity. Then again, you may choose your own test points as long as it is inside the interval. So this is negative 0.5, 0.5, and 2. Okay, so substituting these values to our numerator and denominator, we will have, or we will have these signs here. So the signs are already provided. So we have negative, 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 positive, 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 negative, negative, positive. And for this second to the last row, we have negative divided by positive, negative, negative divided by negative, positive, positive divided by negative, negative, positive divided by positive is positive. So again, our A is above, our B is below. So this is below the x-axis, above the x-axis, below the x-axis, above the x-axis. So let's answer this first. Will the graph cross the horizontal asymptote? To answer this, again, we will equate our function. This is our function. And our horizontal asymptote is y is equal to 0. Okay, so cross multiply. So this is 0 over 1. So cross multiply. So we have 1 times 2x. So we have 1 here. So 1 times 2x. Next, we have 0 times x squared minus 1. So of course, this is 0. So this should be 0. Divide both sides by 2x. Okay, so x is equal to 0. So the graph will cross the horizontal asymptote at the origin. Okay, so it will cross the horizontal asymptote at the origin. So meaning, so remember, the graph will only cross once only. Okay, so we have here, okay, so from negative infinity to negative 1, it should be below the x-axis. So this is the x-axis, so below. So you must draw a curve that looks like this. Okay. So asymptotic to the to the horizontal asymptote and to the vertical asymptote. It should not cross the horizontal asymptote because the point of intersection must be here. Okay. So next, -1, 0. So we have here -1 to 0. This interval, it should be below, it should be above. So above. So we must draw a graph above. Okay, from the point of intersection here, from the x-intercept. Next, below. So from this point, you draw a curve below. And then last, above. So this is the x-axis. Above, it should be here, asymptotic to the vertical asymptote and the horizontal asymptote. Okay, so we have below, above, below, above. The next example. So this is the actual graph. Okay, example 3. So from the previous videos, we have this. So we only have one vertical asymptote. Now this is the y-axis. So this is not a broken line. So this is the y-axis, this is the x-axis. So this is our x equals 3. We only have one vertical asymptote. Then the horizontal asymptote is y equals 3. So this is y equals 3. And the intercepts, this one, the 0, 0. The x and y intercepts are the same, the 0, 0. Okay. So so arrange. So we must arrange first. So we have 3. So okay, x is 3 and 0. So we only have two values, 3 and 0. So this should be 0, 3. Okay. So we have 0 and we have 3. So we only have three intervals from -infinity to 0, 0 to 3, and from 3 to positive infinity. Then again, we'll have these test points. So choose your own test points. And then substitute them to these expressions to get these signs here. So negative divided by negative is positive. Positive divided by negative is negative. Positive divided by positive is positive. So we have now above the x-axis, below the x-axis, above the x-axis. Now let's check first whether the graph will cross the horizontal asymptote or not. So we must equate our function and our horizontal asymptote, which is y equals 3. So cross multiply. So we have 3x times 1 and we have 3 times x minus 3. Okay, and distribute. We have 3x and minus 9. Take note, 3x minus 3x. If I transpose this, this will become negative 3x. So this will become 0. This is equal to negative 9. But of course, this is false. Okay, this is false because 0 is not equal to negative 9. So if this is the case, then we can tell or conclude that the graph will not cross the horizontal asymptote. So it will not cross the horizontal asymptote. So we have here, again, we have above, below, and above. So this is the horizontal asymptote. So take note, it will not cross. So no part of the graph will cross the horizontal asymptote. So first we have -infinity to 0. So this one, -infinity to 0. It should be above the x-axis. So this is the x-axis. So above, so you draw a curve above. Next, 0 to 3. So this one, it should be below. So draw a point from here, asymptotic to the vertical asymptote. Okay. And last, from 3 to positive infinity, it should be above the x-axis. So this is the x-axis. Above. It should not be here because according to our previous slide, it will not cross the horizontal asymptote. So it will not cross, so it should be here. Okay, so that this must be the graph. So this one. So they have above the x-axis, below the x-axis, and this is above the x-axis and also above the horizontal asymptote, because the graph will not intersect the horizontal asymptote. Okay, example 4. So last time we have this. We can simplify this one to x minus 3, x minus 4. Why? Because if we factor this is x minus 1 times x minus 3 and x minus 1 times x minus 4. Okay, so we can cancel x minus 1. And take note that x minus 1 is on the denominator. So for the domain, so if we check the domain, x should not be included. No, 1 must not be included. Okay. But for the vertical asymptote, we will only consider the non-cancelled factor. So we will only consider x minus 4. So from the previous video, we have x equals 4, horizontal asymptote, y equals 1, and we have these intercepts. So x equals 4, so this one. Y equals 1, the horizontal asymptote, this is this one. 3, 0, so this is the x-intercept. 0, 3, 4, so 0, and on the y-axis we have 3, 4, almost 1. Okay, question. Next is to arrange. So what are the values of our x? We have only x equals 4 and 3. So we have 3 and 4. So our intervals therefore are negative infinity to 3, 3 to 4, 4 to positive infinity. So choose your test points. I have 0, 3.5, and 5. So substituting these values here to our numerator and denominator, we have these signs. Okay, so negative divided by negative is positive. Positive divided by negative is negative. Positive divided by positive is positive. So we have above, below, above. Before we draw, let's check first whether the graph will cross the horizontal asymptote or not. So this is now our simplified form of p of x, and this is 1, our horizontal asymptote. So cross multiply. So you have 1 times x minus 3 and 1 times x minus 4, because 1 can be written as 1 over 1. So cross multiply. So we have here, and then x minus x is 0, negative 4 plus 3 is negative 1. Again, this is false. So since this is false, the graph will not cross the horizontal asymptote. So it will not cross the horizontal asymptote. So we have here our partial graph a while ago. So this is a horizontal asymptote, so meaning the graph will not cross here or will not even touch this one. So from negative infinity to positive 3. So here. So you must draw a graph above. So above. Take note, we have here the intercept. So you must cross the intercept, the y-intercept. Okay, it is asymptotic to the horizontal asymptote because, again, the graph will not touch the horizontal asymptote. It will not cross or even touch the horizontal asymptote. So this is above the x-axis because this is our x-axis. Next, 3 to 4, this small area here. So it is below, so below the x-axis, so draw. So asymptotic to the vertical asymptote. And then next, it's above the x-axis. So again, you cannot draw this like this because the graph will not cross the horizontal asymptote. So it should be here. Okay, So the endpoints must be asymptotic to the vertical asymptote and the horizontal asymptote. Okay, so the graph looks like this. Now, take note. Now, why do we have a hole here? Take note that for our domain, 1 should not be part of our domain. X equals 1. That is why on this part, at x equals 1, this is x equals 1, your graph must be a hole. No, there must be a hole. So say, for example, you have a graph here, and then part of the x-axis is, say, for example, this one, 1, is not part of the domain. So you just draw a hole and then proceed with a curve. Okay, just like this. Okay, again, because 1 is not part of the domain. Positive 1 is not part of the domain. That is why we have a hole here. Okay, this is the factored or the cancelled factors. The x minus 1 over x minus 1. Well, we canceled that a while ago. Okay, last, given this expression from the previous videos, we have this information. So 4/3. So here, this is 4/3. X equals positive 4/3. And x equals negative 2 here. So x equals negative 2. Vertical asymptotes. We have two vertical asymptotes. And we have horizontal asymptotes. We have y equals 5/3. So y equals 5/3 is almost 2. No, this is almost 2. So this is 2 man. This line here is 2. So almost 2. So it reaches almost this point. Next, we have 2/5, 0, our x-intercept. So we have a 2/5 here and 2. So these two are our intercept or x-intercept. And we have the y-intercept 0, negative 1/2. So this is on the y-axis negative 1/2. Okay, next. So we arrange. We have these four values: 4/3, negative 2, 2/5, and 2. So the smallest is negative 2, followed by 2/5, then 4/3, and 2. So we have negative 2, we have 2/5, we have 4/3, and we have 2. Then we have negative infinity, and we also have positive infinity. So we have these intervals now: negative infinity to negative 2, negative 2 to 2/5, 2/5 to 4/3, 4/3 to 2, 2 to positive infinity. Then choose your test points. And then substitute. So we have these final signs. Positive divided by positive is positive. Positive divided by negative is negative. Negative divided by negative is positive. Negative divided by positive is negative. And positive divided by positive is positive. So we have now the above, below, above, below, above. But before we graph this one, will the graph cross the horizontal asymptote? So again, to answer this, we will equate the function, this is our function, and the horizontal asymptote, y equals to 5/3. So I multiply this first by FOIL method. Okay, by FOIL method. So we have negative 10x minus 2x is negative 12x. Positive 6x minus 4x is positive 2x. So we have this, and then cross multiply. So we have 3 times 5x squared minus 12x plus 4. And we have 5 times 3x squared plus 2x minus 8. Distribute, we have 15x squared minus 36x, positive 12. Then this is positive 15x squared, positive 10x, and minus 40. Take note, if I transpose one of the 15x squared, it will be negative 15x squared. So this is 0. So we can just cancel this 2. Okay, next I will transpose negative 40 on this side, so it will become positive 40 and copy positive 12. Similarly, negative 36, will be transposed here. So positive 36x and copy 10x. So combining these terms, we have 12 plus 40 is 52. 10x plus 36x is 46x. Then divide both sides by 46x, 46 only. So it is approximately 1.13. So therefore, the graph will cross at 1.13 to and 5 over 3. This is the point. 1.13 and 5 over 3. Now 1 over 3 is, I think, 1.5 over 3 is 1.67. So let's now have this. So we have these points a while ago. The y-intercept, the 2x intercepts. So take note that the graph will cross at where? 1.13 and 5/3. So 1.13 and 5/3. So somewhere here. Now remember, this is x equals, what is this? X equals 4/3. This is x equals 4/3. So 4/3 is 1.33. And our point of intersection is 1.13 and 1.67. Okay, from this point. So meaning it should be before the 1.33 because we are only looking at the x-axis for this port. So and the 1.67 is the horizontal asymptote. So the graph should cross here. Okay, and remember the graph will only cross the horizontal asymptote once. Okay, so let's have negative infinity to negative 2. So this is negative 2. So this point, it should be above the x-axis. So since the point of intersection is here, so it must not cross here. So, and this is the above the x-axis, so it should be above the x-axis and above the horizontal asymptote. Because again, we can only cross once, and it should be here. Next, negative 2 to 2/5. So negative 2 to 2/5. This is 2/5, this one. So it should be below. So from here, below, so you cross the y-intercept. So pababa. So it should be a curve. Next, 2/5 to 4/3. So 2/5 to 4/3. So it should be above. And now we can now cross. This is the point of intersection. So you can now cross the HA or the horizontal asymptote. Next, 4/3 to 2. So this small portion here. So it should be below the x-axis. And last, it should be above. But it will not cross the HA because it already crossed here. Okay, so it will be asymptotic to the horizontal asymptote. So again, this is above, below, above, below, above the x-axis. Okay, so therefore this looks like the graph looks like this. The point of intersection is here. Okay, so this is above, below, above the x-axis, below the x-axis, above the x-axis. So this is the x-axis. So thank you for listening.